Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to talk about how to do mental math, right? Well, one of the ways in which we can do mental math with multiplication. All right. As you see, I got my Lincoln University t-shirt on. Lincoln University is a historically black college located in Pennsylvania. That's where I happen to get my master's degree from. And also a lot of very important people of African descent attended Lincoln University, such as Langston Hughes, Thurgood Marshall, but people such as, that you may not be aware of, like Kwame Nkrumah, who ended up becoming the first president of an independent Ghana in 1958. Also Nnamdi Azikiwe, who was a Nigerian. Kwame Nkrumah was from Ghana, was from present-day Ghana. Nnamdi Azikiwe was from Nigeria. After spending some time at Howard University, Nnamdi Azikiwe transferred to Lincoln University in Pennsylvania. And then before going back to Nigeria and becoming a journalist and later a leader, a political leader in Nigeria as well. But definitely do your research on Lincoln University and the people that it has produced throughout its own history, you know? All right, and also the other HBCUs. As you can see on the back of this t-shirt, all the HBCUs are listed on the back of this t-shirt. So definitely do your research on historically black colleges and universities, all right? Now, let's get into this multiplication, because this method of multiplication is very helpful. It's very helpful. And the method that we're actually using is called the distributive property. The thing about the distributive property is that it's something that is usually introduced in high school or in algebra, because it's used all the time in algebra, right? But the thing is, you can use it when you're just, multiplying integers or multiplying like numbers like these, like 87 and 4. 54 and 3, or 98 and 6, right? And basically, like, some of you might, know people that actually do this already, right? Now, if you see 87 times 4 off the top of your head, you probably don't have 87 times 4 just memorized, right? But there's ways that you can break numbers down and break them apart into more manageable pieces in order to figure out what the products of that number and another number is. So check this out. If I got 87 times 4 seems complicated to me because 87 is a large number, right? But what if I broke 87 down into two more manageable numbers, or numbers that are easier to deal with? Like, what if I broke 87 down into 80 and 7, right? Now, I call 80 a happy number, right? I spell that H-A-P-I, like happy, like the Happy River, like what our ancestors called the Nile River way back in the day, right? So this is like a connection to Africa, right? Because when I do math, I like to think about Africa when I'm doing math. It just makes me feel good, you know what I'm saying? So I break 87 down into 80 and 7. My happy number is 80, and I got 7 left over, right? So let's say I do this. 80 plus 7. 87 is the same thing as 80 plus 7, right? And then the times 4 is still there, right? Now, this is where the distributive property comes in, because I basically am distributing this 4 to everything inside the parentheses. Again, I'm basically distributing that 4 to everything inside the parentheses. The 4 gets distributed to the 7. The 4 gets distributed to the 80. So we're going to do 4 times 7. We also going to do 4 times 80. Now you might think, well, 80 times 4, 80 is a big number. So how am I going to know what 80 times 4 is? Check this out. This is why it's a happy number. Because this 0, I can pretend like that 0 ain't even there momentarily, right? And if I know my multiplication facts, I can act like this is just an 8. And I could do 8 times 4. And I know that 8 times 4 is 32. So if 8 times 4 is 32, then I can do that. And then I reattach the 0. So then what I have is 80 times 4 is actually 320. That's another math trick. It's like a cheat code when you're playing video games, right? It's a cheat code. You can pretend like the 0 is not there. That's why I call it a happy number, because it makes me happy. Also makes me happy that the math becomes easier when I use different tricks like this. So that 80 becomes an 8. I do 8 times 4. I know my multiplication facts. That's 32. Because that's 32, then I got to reattach the 0. That gives me 320. Then I do 7 times 4 or 4 times 7, however which way you want to look at it. And that's going to be plus 28. Because 7 times 4 is 28. Then I'm doing 320 plus 28. Right? So now, more mental math. I can actually break this down into a happy number and another number. I can break this down into 20 and 8. So 320 plus 20 is going to be 340. 340. Plus the 8 that's left over, 340 plus 8 is 348. And that's your final answer, 348. And hopefully over time, after implementing this method, you'll be able to do mental math with large numbers, right? Now let's check out the second example, 54 times 3. So let's say I see 54 times 3. Let's say I'm going to break 54 now because that's the 2-digit number. So whatever your 2-digit number, you want to break that down into a happy number and whatever's left over. Happy number and the leftovers. Happy number and the leftovers. So the happy number is going to be 50. The leftovers is going to be 4, right? So I got 50 plus 4. So 54 is the same thing as 50 plus 4. All right, just like 87 is the same thing as 80 plus 7. When we get down here, well, I'll wait till we get there. And then we got times 3. So we're going to do 50 times 3 and 4 times 3, right? 50 times 3 is the same thing as 5 times 3 with a 0 attached to it. So what's 5 times 3? 15. What's 15 with a 0 attached to it? 150. So I got 150 right there. And then I got 4 times 3. That's 12. And then I'm going to do 150 plus 12. I can think of it like 12 as like 10 and 2. 10 and 2. So 150 plus 10 is 160. And then the 2 that's left over, 160 plus 2 is 162. Boom. All right. Last but not least, 98 times 6. Now, here's another thing. Check this out. I'm going to do it the way we did the first two. Then I'm going to do it another way, right? Just to show you how many options we have in math. That's another reason that I love math, because math gives you so many options in terms of problem solving. It just gives you a lot of options, right? So we got 98 times 6. So I'm going to break 98 down into 90 plus 8. 90 plus 8, right? Now, normally I would do this in my head, but I'm writing it down to show you what it looks like. So 90 plus 8 times 6, right? Okay. Now we got 90 times 6. That's the same thing as saying 9 times 6 with a 0 attached to it. 9 times 6 with a 0 attached to it. Make sure you know your multiplication facts. 9 times 6 is 54. 54 with a 0 attached to it is 540, right? And then, so that's 90 times 6. And then I got to do 8 times 6, which is 48. So I got 540 and I got 48. 540 and I got 48. 540 and 48. I could break the 48 down into 40 and 8. 40 and 8. So 540 plus 40 is 580, right? 580, because that's just 4 tens, right? So 540, it's almost like doing 54 plus 4. 54 plus 4 would be 58. So 540 plus 40 would be 580. 58 with a 0 attached to it. You see how we keep doing that? That's that same cheat code. We keep using it over and over again. When you have a 0 at the end, that makes the math a lot easier, all right? So we got 580 plus the 8 is 588. Now this is our answer, but I'm gonna show you another way we could have got it, because 98 is so close to 100, right? 98 is so close to 100. I could have did this. What if I did this, right? Instead of doing 90 plus 8, I could also use subtraction, because I know how to subtract. I also know that 98 is the same thing as saying this. 100 is also a happy number because it ends in 0. 100 minus 2. Isn't 100 minus 2 the same thing as 98? It is, right? Just like 90 plus 8 is the same thing as 98. Like if you had $90 and then you got $8 more, you would have $98. Or if you started out with $100 and you spent $2, now you still got $98. Either way, the value of those expressions, 90 plus 8 and 100 minus 2, is still 98 regardless, right? So I got 100 minus 2 times 6. Now watch what happens when I do this. I'm going to do 100 times 6. 100 times 6 is 600. You know why? Because 1 times 6 is 6. Except now I got 2 zeros to attach instead of just the 1 0 to attach. I got 2 zeros to attach, right? So I got 1 times 6, which is 6, attached to 2 zeros, you get 600. Now, 2 times 6. What's 2 times 6? 12. Make sure you know your multiplication facts. I'm telling you, right? So we got minus 12. So 600 minus 12. I could break the 12 down into 10 and 2. 10 and 2. 10 and 2. I can subtract 10 from 600. That gives me 590, right? But then I got to subtract the other 2. What's 590 minus 2? 588. Just like we had. So I wanted to show this to you like 2 different ways. And we could have did, like with this one, we could have did 60 minus 6. Because that's still equal to 54. We could have did 90 minus 3 for this one instead of 80 plus 7. Because that's still equal to 87. But I want you to understand that you got a lot of options. When we do math, we have options. That's one of the, as I said, that's one of the reasons that I like math so much, is because math provides us with a lot of options for problem solving, right? And that's good. That's a good thing, because a lot of times when we're presented with problems, we want to have multiple options for solving the problem. We don't want to just be locked into one method, because that one method might not work all the time, or it might not be available to us, or we might need a certain tool where that's not available in order to problem solve this one way. But if you're locked into only that one way, then if you don't have all the tools available to you that you need, then you just won't be able to solve the problem. So you want to have options. You want to be aware of options, and you also want to be comfortable with options. All right. So let that marinate. Think about that a lot. Also, as you're doing mental math, you find yourself out in the world, out and about. If you ever have the opportunity to multiply a 2-digit number by a 1-digit number, practice this. Practice this on a regular basis, so this will become part of your mental math, process. One of the ways that you do mental math in your head. You know what I mean? And I'm telling you, it'll be very helpful. All right. So when you see problems like this, see examples like this out in the world, do the math, use these methods, and I'll catch up with you on the next video. Peace.